Well, as a matter of fact, I'm going to present this collaborative work done by my PhD student, Andrea Marcucci, and master student, Gloria, together with these colleagues, Stefano Guanziroli and Marco Borroni from a company with whom we have developed this, 3D printing inspired, I will say, technology for tunnel retrofitting. So let me just introduce the topic. You can see this is the map of Italy, like a booth. And as a matter of fact, because of the orography of our country, we have this spine of mountains going from north to south. We have to build tunnels in order to go from one side of the country to the other. We are actually the first country in Europe for the length of the tunnel network, more than 1,500 kilometers of tunnel. Many of them built during the 60s, so when there was the boom of the transportation infrastructures throughout Europe. So many of them likewise in sometimes strong need of maintenance. Interesting is also the case of railway tunnels. Railway tunnels were built even before the railway network development, dated back to the late 19th century. So these are tunnels which in most of the cases are also not of concrete. So what does it happen when you need to make some works on a tunnel on a highway? This. Typically, you have to close the one lane or the other of the highway, which makes the traffic to be heavily disrupted. And if this is annoying for each one of us as a driver or as a passenger in the car, especially if the destination to be reached is a pleasant one for holidays and so on, which makes this more likely to happen because of the people are on the highway. This has also a very strong economic impact. So you see, it has been estimated a loss in gross domestic product of 36,000 euros per kilometer per day of disruption of the traffic on the highways. And also for each household, if each one of us want to, mind his own garden, his own backyard, this results into a loss of 3,500 euros per year per each household in money that you really cannot predict and control where does it go. So which is the technologies that we currently employ? Scrape, perform some temporary lining works in case using shotcrete, and then go with a cast-in-place or partially precast solution using different kinds of concrete. The 3D printed inspired idea that we had, and I will come with the next slide, is this one with this company, Infra. We developed this extruded tunnel lining regeneration technology. There is this, train, and you have this scraping modulus here with which you remove the damaged part of the existing lining, and this formwork part, which acts as a bottom formwork in the lining, the top one being the existing tunnel lining. Where the 3D printing inspiration came from, because with the chairman of this company, which was a former student of ours, we were working on 3D printing, and you can see this robot, we use it for 3D printing filament. But then the same mix design technology, you have a mix that must be fluid when you pump and extrude it, and then must be rapidly gain its strength. We started saying, okay, why don't we try to shape it in the form of a vault and try to apply to this technology? So the 3D printing inspiration came in mixed design technology. And you see, we built up in the beginning this very small, actually was about 0.5 meter diameter, very small molds in which we pumped through this robotic arm and related pumping circuit. The mix, it hardens, and then we slip formed. It was not exactly an extrusion based, but the concept was similar. And these are the early attempts that we made with mixes, which we derived exactly from the 3D printing technology. So the company in the end built up a testing bed, I will say half scale, because this is a diameter of the lining of about 5 meters, whereas on highways we have diameters going between 9 and a little bit less than 11 meters. And these steel frames act as a replica of the existing tunnel, and this is the formwork part. There is a pumping circuit, you pump the concrete, and when it's ready to be slip formed, you go from this. You can see the slip forming machine is moving, and I hope this, movie works as well. So in very short time frame, which is about a couple of hours, we must go from a self-compacting mix, which has to be pumped, to a mix which is self-standing. And these are the results of the very early age, we started measuring at 4 hours. At 4 hours is already hardened. You can use regularly testing protocols and so on. Well, as you can see, at 4 hours, we already have about 15, 20 megapascal strength, compressive strength. But this is fiber reinforced, and one of the advantages of using this kind of mixes in tunnel linings is that you can completely eliminate the conventional reinforcement, which results in very great savings in the time, in construction time, and so on. And also savings, in some cases, in the quantity of reinforcement. But in order to do that, you must have a fiber-reinforced concrete mixes which satisfy some performance requirements, which you can control with three-point bending test according to European standard. It's a notched beam, and you test in three-point bending, and you plot the results in terms of nominal flexural strength versus crack mouth opening displacement. The characteristic value of this first strength, the first one at 0.5 millimeter, gives you this number that you can see here, class 3, class 4, class 6. That means that you have a characteristic value of that residual strength equal to 3, 4, 6 megapascal. And the letter, E or D in the case that we are working on and are requirements for the applications where you want to eliminate the conventional reinforcement, E means that the ratio between this stress here at 2.5 millimeter and this stress here at 0.5 millimeter is higher than 1.3. And class D means that that ratio is between 1.1 and 1.3. So you must have a very stable and reliable deflection hardening response. Deflection hardening, it does not mean that the material is strain hardening, because you have to go from flexural response to direct tension through back analysis, and you have some factors there. So we did perform the test also at 4, 8 hours, and 24 hours, and you see we got at 4 hours, we had this average value with this scattering. You see how does it increase. So the first step that we made was, okay, at 4 hours, which is the first age we were able to make the test according to the hardened state, and we can use conventionally solid mechanics tools to analyze, is our tunnel lining safe? What does it mean safe? Well, first of all, it must self-stand. It must resist its own self-weight. But then it can accidentally happen that the existing lining, which continues to perform its duty, fails somewhere. So when it does, it transmits all the loadings to the new lining. So we wanted to check also these accidental situations are actually these situations here, these dots here in the moment-axial force interaction diagram. But these diagrams show that starting from 4 hours and applying this, that means that we applied all the partial design safety factors to the material properties, the safety check is okay. But then also we asked what happens between 0 and 4 hours, because that is likewise extremely important in order to assess the productivity of this technology. When can we slip form to be sure that not only from the safety point of view, because in that case you can avoid people to stay in the lining, you can adopt safety measures, but for the functionality and the productivity of the technology. And most of all, what kind of methodology, what kind of approach shall we use in order to describe the behavior of a concrete which is undergoing a fluid to solid transition? It's no longer a fluid, so we cannot model any longer with a Bingham model, but it's still not a solid, so we cannot apply the usual finite element tools that we apply for solid structures. So actually the analogy between 3D printed concrete, between concrete in some stages of its life and soil, it's quite well known. So we use the Moore-Coulomb criterion, which is typically used for cohesive granular soil. So we basically have to identify the cohesive stress and the angle of friction. So we performed compression test and shear test at ages, you can see here, that go from 45 to 75 minutes, and in some cases up to 2 hours, because it happened, we verified in our real case test that if you cast, for example, during summer, the mix can be extremely rapidly hardening, which does not comply with the productivity in the sense that you cannot cast at a certain point. So in some cases, for some climates, we had to use some retarder and wanted to see also the effect in this case. So these are some of the results for the compressive stress curves that we got, and you see here the typical shear band localization that we experience in compressive tests of cohesive or frictional materials like concrete. And we also made did set up like for shear box test in rocks. We applied for our concrete in fresh state. You can see the sample of concrete is here. And in order to obtain the more Coulomb envelope, we also applied different levels of normal pressure because we did the test at 3 levels of normal pressure. And we had results like this. These are the curves. We could identify peak stress and residual stresses, obviously evolving with time. So we were able to identify the representative more Coulomb parameters for our material. And in the end, we were able, at this point, with the identified more Coulomb criterion parameters, we were able to perform an analysis for the transient design situation of our tunnel lining. We exploited the symmetry, so we modeled only half. So in the beginning, everything was frozen. And at a certain point, we removed these constraints here on the inner vault of the lining just to simulate the fact that the formwork is slipping, and so there is no longer a support. And as a matter of fact, we realized that, for example, in the very early minutes that we checked, up to 1 hour, we still have a very, very huge deflection, even if we never exceed the plastic strains except locally. So the lining is globally safe, but still experiences a deformation which is absolutely not compatible for the functionality of the technology. At 75 minutes, we just experienced a few centimeters, which is okay. But then, in the end, we wanted to see, okay, but when can we really slip form? When we really have displacements that can be accepted. So on. Obviously, if you perform an elastic analysis, you will always have a displacement if you don't anchor because it's there. So we extrapolated and we merged the results at the very early ages, so up to 2 hours with one that we had at 4 hours to find the transition function. And we realized that, for example, at about 2 hours, we have displacement in the range of 2 to 3 millimeters, which is deemed to be satisfactory and acceptable for the productivity of the technology. So just quickly coming to the conclusions. We have developed this, how to say, 3D printing inspired self-compacting fiber reinforced concrete with very rapid strength gain, which proved an interesting solution for this tunnel retrofitting technology that we developed. Obviously, the key properties are exactly the properties in ages going, how to say, from a few hours up to 1 day, which are the critical times where you have to design whether to advance with your slip forming technology and how safe is your ongoing tunnel lining in order to go on with the operation, because at a certain point you must also allow the crew of the workers to go into the lining, and so you have to guarantee a certain level of safety. As a matter of fact, when you go from transitioning in concrete from fluid to solid state, there is this grain zone where we apply the more Coulomb model, a more Coulomb criterion to model the behavior of concrete, and we performed a dedicated experimental investigation to identify and to calibrate the model parameter. And we were able to find a reasonable solution for the demolding or the slip forming of our tunnel, which complies safety requirements, integrity of the structures, and productivity of the technology as well. And I thank you very much for your attention.